spend another day looking at absolute value inequalities. Let's start with the warm-up. Write the solution and graph each on a number line. So the first one is the absolute value of x is less than 6. So for this one, change my line here. If the absolute value of x is less than 6, remember, first let's split it up into two answers. X can be 6 and x can be negative 6. But this is less than. So if it's less than, it's between from yesterday. So x is less than negative 6. I'm sorry, negative 6 is less than x, which is less than 6. So this one's in between. If it's less than, it's in between. We're going to do an open dot at negative 6, an open dot at 6, and then we're going to color in between. So all of these numbers right here are less than 6 if you take the absolute value of the numbers. The absolute value of negative 5 is 5, and 5 is less than 6. 3 is less than 6. You can test any of these numbers, and they're all less than 6. So if it's less than, it's between. If it's greater than, it's beyond. So again, we split it up into 2x, and I shouldn't have put my absolute value signs here or here. All right, so this one's split up. Again, x can be 6, x can be negative 6. Again, open dot because there's no equal sign. But here's x is greater than, so this is the one that's beyond. So all of these numbers are bigger than 6, and the absolute value of all these negative numbers are also bigger than 6. So our solution is x is less than negative 7, and x is greater, oh, this should be negative 6, I'm sorry. X is less than negative 6, and x is greater than positive 6. So this one is between. And this one, if it's greater than, it's beyond those numbers. Okay, so less than, between, greater than, beyond. So the learning target today, I can solve and graph absolute value inequalities that require more than one step. So let's see if I can quit workspace here. Okay, so now we're going to look at more than one step inequalities, and we're going to solve pretty much the same way. So the first one is less than and less than or equal to, which is between. So that's like the first one in the warm-up that we did. So here are the steps. Solve the inequality. Remember to get rid of everything outside the absolute value before splitting it up to plus and minus, and your answer will be between. So the first one right here, we have the absolute value of 3 minus 2z is less than or equal to 5. There's no numbers on the outside the absolute value, so we can split it up right away and do 3 minus 2z is less than or is equal to, I'll put equal to 5. And 3 minus 2z is equal to negative 5. So split it up into the plus and the minus. We're going to solve, so we'll subtract 3. I'm going to switch colors here. Subtract 3 from each side. We'll get negative 2z equals 2. Divide by negative 2. So z will be negative 1. And let's solve the other one. I'll use a different color here. Subtract 3 from each side first. Negative 2z equals negative 8. Divide by negative 2. So z equals 4. So this one right here, it's between negative 1 and 4. So negative 1 is less than or equal to z, which is less than or equal to 4. If we were to graph it, at negative 1 there'd be a closed dot. At 4 there'd be a closed dot. And it would be everything in between. All of these numbers would work. And you can check your answer by plugging in any of those numbers. Negative 1 to 4 should work and be less than or equal to 5 when you plug in. Let's try the next one. There are some numbers on the outside of this absolute value. So we're going to get rid of those numbers first before we split it up into plus and minus. So the first step is subtract 15 from each side. We get negative 3 times the absolute value of x minus 5 is less than 0. Let's divide by negative 3. And we get x minus 5 is less than 0 still. Now we split it up. So x minus 5 equals 0, and 0 is plus or minus, so we're going to add 5 to each side, and we get x equals 5. Let's plug in and check our answer. So here there's only 1 because of this 0, but let's plug it in. We have 5 minus 5 is 0, and we have 0, negative 3 times 0 plus 15 should be less than 15. And this is 0, so we have 15 is less than 15. And so this inequality we should have kept like this. X is less than 5. So let's graph this on a number line. So here's 5, and it's when x is less than 5. And let's double check and make sure that numbers work less than 5. So let's plug in, how about a 1. A 1 is less than 5. So we have 1 minus 5 is negative 4. The absolute value of negative 4 is 4. 4 times negative 3 is negative 12. Plus 15 is less than 15. All right, so if you get a 0, one answer, then it's just going to be everything less than, x is going to be less than our answer 5 right here. So there it is. Okay, let's try the next one. Again, there's numbers on the outside, so we want to get rid of them first. So here, first we're going to add 22 to each side first. We'll get the absolute value of x over 3 is less than or equal to, and this would be negative, actually this would be positive 2. And then we're going to get rid of the divided by 3 by multiplying by 3. So we have the absolute value of x is less than or equal to 6. Now we split it up. X can be 6, x can be negative 6, and it's going to be between them. So here's negative 6, close dot, positive 6, close dot, and you color everything between. And if we write the notation, negative 6 is less than or equal to x, which is less than or equal to 6. Put the small number first, less than or equal to x, less than or equal to 6. Let's try D is slightly different. Everything is being divided by 2. So this one you added 22 first, then multiplied by 3. But for D, we're just going to multiply by 2 first because everything is in that fraction. So first, I'm trying to make this bigger here. It's not letting me make it bigger. Okay, we'll leave it. So first step, multiply by 2. And we'll get absolute value of 4x minus 12 is less than 20. Now we can split it up into the plus and minus. So 4x minus 12 equals 20, and 4x minus 12 can equal negative 20. And we'll add 12 to each side. So we get 4x equals 32, and we get 4x equals 8. And we'll divide by 4. So we get two answers, x equals 8 and x equals 2. Oh, and this should have been a negative. So this will be a negative 2. Okay, so here x is between 8 and negative 2. So if we were to graph it, here's a negative 2, open dot here because of no equal sign, and 8, there'd be an open dot. And we'll shade everything between. Let's check an answer. 0 is somewhere in between here. Actually, 0 would be closer to the negative 2, huh? So here's 0. Let's plug in and make sure it works. So we get negative 12 over 2. 6 over 2 is 3. Yep, 3 is less than 10. That does work. So you can check your answer. To write the notation, we start with our lowest number. Negative 2 is less than x, which is less than 8. So this would be the notation, and there would be what the graph looks like. Okay. Okay, so that's in between when it's less than or equal to. When it's greater than or equal to, it's beyond. So we'll take a look at some examples. Again, get rid of everything outside first before you split it up into plus and minus. This one, in the first example, A, there's nothing on the outside. There we go. So we can split it up right away. We get 2 minus 6y equals 10. 2 minus 6y equals negative 10. We'll subtract 2 from every side here. We'll get negative 6y equals negative 12. Negative 6y equals, this is negative 12. I'm sorry, this is not negative 12. This will be 8. Divide by negative 6. So we get y equals 8 over negative 6. Let's get the decimal and see where that falls on the number line. So it's about negative 1.3. It's negative 1.3 repeating, and this is positive 2. So right here it's beyond. So here's negative 1.3, and here's positive 2. Open circle, and it's going to be greater than the biggest number. It's going to be smaller than the smallest number. So we say x is less than negative 1.3, and x is greater than 2. So 2 answers here. And again, you can plug in numbers and check to make sure they work. All right, let's try the next one, B. There's numbers on the outside, get rid of them first. Subtract 14 from each side first. We get negative 2x plus 3. Negative absolute value of 2x plus 3 is greater than or equal to negative 15. There's an invisible negative 1 here. Let's divide by it to get rid of it. We get 2x plus 3 is greater than or equal to 15. Split it up. 2x plus 3 equals 15. 2x plus 3 equals negative 15. And solve each one. So minus 3 from each side. Subtract 3. We'll get 2x equals 2. And we'll get 2x equals negative 18. And we'll divide by 2. And so we have 2 answers. X is 1 and x is negative 9. So if we were to graph this, negative 9 is my smallest number, a closed dot, and it would be smaller than the smallest number. And here's 1, it'd be bigger than the biggest number. And again, you can plug in your answers and check, like let's plug in a 2 because it's bigger than 1. 2 times 2 is 4, 4 plus 3 is 7. You'd have negative absolute value of 7 plus 14 is greater than or equal to negative 1, and that does work. Okay, so if we write this up as a solution, x is less than or equal to negative 9, and x is greater than or equal to 1. Okay, let's look at the last two, C and D. And this one gives us choices, so let's solve and find our choice. So this one, get rid of numbers on the outside first. Subtract 7 from each side, we get 2x over 3 is greater than or equal to 4. Multiply each side by 3. We get the absolute value of 2x is greater than or equal to 12. Split it up. 2x equals 12. 2x equals negative 12. Divide by 2. And we get x equals 6 and x equals negative 6. And it's beyond them, so it's going to be, if I graph this right here, let's see, we have our negative 6, closed dot, positive 6, closed dot, greater than the bigger number, smaller than the smallest. So x is going to be greater than or equal to 6 and less than or equal to negative 6. So A is the correct answer. Okay, there's one more for D. Again, I'll take a screenshot of this. And we'll take a look at our answers. I should have taken a screenshot of the whole thing. I'll redo that. Okay, so first get rid of the divided by 4 by multiplying by 4. We get absolute value of x minus 7 greater than or equal to 32. Split it up, x minus 7 equals 32. X minus 7 equals negative 32. We will add 7 to each side. So we get x equals 39. We get x equals, we got negative 32 plus 7, negative 25. All right, so if we were to graph this, negative 25 is our small number, 39 is our big. There's an equal sign, so fill it in. And so x is less than or equal to negative 25, and x is greater than or equal to 39. So it's, again, A for this one. Now the last two are no solution, and here's why. When you get the number by itself for each of these, so this one you multiply by 2, you get x minus 3. The absolute value of x minus 3 is less than or equal to negative 12. We know an absolute value has to be a positive number, and this is negative. So if you get the absolute value by itself and the answer is negative, there's going to be no solution. Same with this one. If we add 10 to each side, we get the absolute value of x over 3 is greater than or equal to negative 4. We multiply by 3. And we get the absolute value of x is greater than or equal to negative. Again, we get a negative number, and the absolute value cannot be negative. So sometimes there's no solution. All right, so we're going to try this again, absolute value. We'll spend another day in it tomorrow. So take a look at these examples, and you can try your assignment.